Alright, we're looking at 6.2 lines of best fit. Our goal is to sketch a line of best fit and determine the equation of the line. I hope this section was as easy as the last one was for you guys. I hope it should be. It's not a lot to it. There's a lot to write down. There's not a lot of concepts to it. It's not very difficult, so hopefully you guys will follow and find it pretty easily. The first example gives us foreign-born players in a hockey league. So give us this chart, and then it says how might the percentage of players of the year 2020 compare with 1993. So we have information on 1990 and 1995. We don't have 1993, but based on this pattern here, we can see as the year increases, we can see that these numbers are increasing, generally speaking. Okay? Notice that there is, or there can be, a blip in the data. Okay, anybody see the blip in this data? When I say a blip, I'm referring to an outlier, so it doesn't follow the regular pattern. Carlson?
1960.
Right, so in 1960, you can see that there was actually less of a percentage of foreign-born players than in 1955. So every other data point, as the year increases, so does the percentage of foreign-born players. So right here, this is known as an outlier. Okay, so right here, sorry. This point here, this is known as an outlier. Okay? And the reason that it's important that we see that or notice that is that we don't choose this point when we decide to use algebra later. Okay, that's why that's important, because when we go to use algebra, we're going to pick 2 points. It's very important that you identify that one of these points is not following the pattern. Okay? How did we find previously whether or not this graph was a straight line or not, besides actually graphing it? Noah? Good, so we could check the first differences here. First differences between these two and these two. And what we notice is right away is that the first differences aren't the same. And the reason for that is because of this blip. Okay? But not only that, there might not be the same, even without a blip, they might not be the same. Anybody tell me why? Yeah.
Like for example, from 1950 to 1955, it increases by 3. And then when you get to 1965 to 1970, it increases by 1, and like the increasing rate changes.
Exactly. So from point to point, from every 5 years to 5 years, the rate at which it's changing is not exactly the same. So because of that, we can't use our table method to see if this is linear or not. At least to use that as a decision maker. Because what we find is that the first differences aren't the same. So technically, if you think about it, it's not exactly linear. Okay? So to answer that question, no, but the pattern is linear. Okay, we're going to talk a little bit about that more now. So how might the percentage of players of the year 2020 compare with 1993? So the first thing we want to do, there's 2 ways we can do this. One is algebraically, and one is by using a graph. It's important that you understand how to use both. On a test, they could ask you to use one or the other. I might show you a graph, I might tell you to graph it, and use a graph to determine it. I might tell you to determine it algebraically. Okay? I personally prefer the algebraic method. It's more accurate. I get kind of a set answer. Actually, it might not be more accurate. We'll talk about that in a little minute. In a minute. But I like it because it's quicker. I find it quicker rather than graphing. Most of you guys probably feel the same way. You don't like graphing, but nevertheless, it's important you understand how to do it. So I take those data points, I plot them out. Okay, very roughly I've shown here on the board. But what we see is, as the year increases, we see that the actual percentage of foreign players is also increasing. Again, important to decide what's independent and what's dependent. Can anybody tell me, is there any way I could have decided that this went the other way around? Is there any way, Matthew? Yeah, exactly. For the most part, whenever you have time, it's independent. Okay? You're not necessarily measuring the year. You're not measuring it. You're choosing the amount of years that you're going to monitor this for. And you're measuring the percent of foreign players. So I hope that's pretty clear to you guys by now. what's dependent and what's independent. Because that would mess you up if you flip these. So in this particular case, you can't really flip them. So the question says, how might the percentage of players of the year 2020 compare with 1993? So if we look at 1993, we're looking at this area in here. And if we look at 2020, we're looking at this area in here. We're just going over that definition, right? I'm sorry, I should say 1993 is this area, right? Because that's the year, the x-coordinate. We can see our data point for 1993 is right here, so that corresponds to a percentage of around, looks like 60 there, but I think it's closer to 50. If it was graphed, well, let's see. In 1993, yeah, it would be just under 50. So it'd be right around 50. So graph again, not that accurate, but you get the idea. All right. Any questions about that so far? My graph's a little messy, but we can say we can make an assumption here in 1920 or 2020. Is it going to be down here or is it going to be somewhere up here? What do you guys think?
Up there.
So everyone's saying up. So if we kind of visualize this pattern, what we see happening then, we'll take a ruler here. And so I'm going to draw a line of best fit. And some of you guys might have done this on Khan already. But what you want to do when you draw a line of best fit, you don't have to go through, first of all, you don't have to go through any dots at all. If you don't want to. Or if you don't feel like that's the best fit, you don't go through any dots. It's fine. You want to try and balance the number of dots on the left-hand side with the number of dots on the right-hand side. Okay? If we do have like an outlier dot like that, you know, I wouldn't necessarily count these two dots or even consider them at all. Okay? If they're totally out, they could be an anomaly. So you don't even consider them. But the idea is that you draw a line through kind of as many dots as you can, or a balanced number of dots on either side of that line. Okay? That's what the line of best fit does. Josh?
I did that on Khan, but then when I went to go next question, it never went there. I just went next question, and I did the exact same thing. And I got it right, but I just clicked into the next question for the line of best fit.
Okay. Show me on Khan in the other class and I'll help you, okay? So now I have this line of best fit. What it allows me to do then, I look at the year that they're asking me the question for, and I can see then from up here, I'm going to draw my line now horizontal, parallel to the x-axis. I'm going to draw a line back to the y-axis. So what that'll do is give me an estimate for the percentage of foreign players. Right? And I'm right around 100. Let's say, you know, it can't go above 100 obviously because it's a percentage, but we can say, in general, we can say that definitely the percentage in 2020 is going to be greater. Okay, I think we can say that with a lot of confidence, that the percentage is going to be greater based on that pattern. Yeah.
For Khan, what happened is when I started, it just gave me like this really long numbered code and it stretched my screen.
Okay, so if it's a technical issue with Khan, we'll talk about it in tech class. Okay? Alright, so any questions there? So that's the line of best fit. That's the kind of pattern that we want to follow. You want to balance the number of dots on either side. Alright, so now we're showing that same example, but we're using algebra this time. I'm going to choose 2 points. Okay? And there is some margin of error here. And there is a potential for something to go very wrong. Okay, depending on the points that you choose. So it might be important, even using algebra, that you have this graph to make a decision on what points to choose. Okay, and the reason I say that is because if you don't notice it here, if you don't notice this outlier or this pattern of it where it dips where it should have went up, then you might choose this as your first point. Okay, which is 1960, 30. You know, let's say it's down there. I'm just exaggerating it a little bit. But let's say it's down here, right? Now you choose another point which is in the middle of the trend right here. Okay? So you might get this slope that, looks, I missed the point there, but you get the idea. If you choose 2 points that are off, say you choose this point and this point, you're going to get this slope that's really not reflective of the data. You guys understand that? So that's why it's important when you go to choose 2 points algebraically, and it can be any 2 points, you pick 2 points that seem to be following the trend. Okay, that you don't choose an outlier. That's important.
Is it best if you always pick like the first point?
Not necessarily, because if that first point is off, let's say that first point is up there, no. Okay, that's why you either got to graph it so you can see that visually, or you just take a look at this and see that the 2 points are following a pattern. Okay, so in this particular case, you can see the points I've chosen are 1980 and 2010. So definitely would do a bit of a spread. I probably would have done a bigger spread than this. Probably would have chose a point in here somewhere and a point towards the end. And that gives you kind of a range of the data. All right? Once we choose those 2 points, it's the simple algebra that we've gotten used to now, where we're finding the equation of the line. The reason we do that is that once we have the equation of the line, we can make predictions on any values. Okay, you'll see that in the next question. Yeah?
So you can pick any of the points throughout graph.
Yes. You just don't want to pick an outlier point, okay? Something that's not following the pattern. All right? So once I do that, I get my 2 points. Again, this is right from the table. I find my slope, which is y2 minus y1 over x2 minus x1. So we're doing 55 minus 42. We get 13 over 30. I plug that into my equation for a line y equals mx plus b, where 30 over 30 is my slope. To solve for the y-intercept now b, I'm going to use one of those 2 points and sub it in to find b. And you guys should be very familiar with how to do this by now. Once I do that, I solve for b, and I end up with my final equation of the line, which is here. Okay? Once I do that, now I can predict an exact value in the year 2020, the percentage of foreign players. So I plug in, the way to do that, I plug in that value for x. So x, remember, is representing the time. It's on the x-axis. And I solve for my value of y. So I end up with 59.3. You can see how off my actual, my very rough sketch graph is. It's quite a bit off. If you look at the textbook, they did it much closer to the same value. I think they got 60% using their graph. So this was way off. It should have been down here somewhere. So you get an idea with the roughness of that graph, how you can easily be off that much. Yeah, the back.
Would it be 41 instead of 42?
1980? Yeah.
That might be a difference.
Wouldn't make any difference, no, you're right. Yeah, the book made that mistake. Yeah. So I copied that from the book. That was a mistake. The book also said example 4 when it's example 3. I will stop there, we'll finish after.